What is going on, everyone? I'm back again today with a video on how to do a proof in geometry. This one's going to involve using the triangle congruences that you would have already learned by now, and also CPCTC. Okay, so let's get started. They want us to prove that KJ, this segment, is congruent to IJ, that segment. And usually they're going to give you some stuff to work with. So the stuff that we're given to work with is that high is congruent to HK. So this piece is congruent to that piece, and I'll go ahead and fill that in. They also gave me that HJ is perpendicular. That's what that sign means, to KI. So I got this piece is perpendicular to that piece, and that's going to have some significance for us and allow us to do this proof. So here we go. In geometry, this is the structure of a geometry proof. You've got your statements on the left. They'll be written in columns like this, and you'll have your reasons that you can make each of those statements over here on the right. In geometry, when you're doing a proof, almost 100% of the time, not quite 100, but most every time that I've seen or done one of these proofs, you start off with these given statements. You might be able to adjust it a little bit, if you have a different style or just want to have a different progression in the proof, that's fine. But your safe bet is to go ahead and start off with what you're given. So I'm going to do that. First thing that I'll say is that segment HI is congruent to segment HK. Why is it that I'm able to make this statement? That's what the reasons are over here for. Every time I make a statement, the reason has to back it up as to why I'm able to make that statement. Well, this is easy. When you start off a proof in geometry, you're going to start off with your reason as given. So this was given to me in the problem. I filled it in up here with tick marks. Now, next thing I'm going to do is say the other given, that segment HJ is perpendicular to segment KI. This is also given to me. These are things that I don't really have to think too hard. I can just start off the proof saying, hey, guess what? This is what was given to me, and now we're going to build on it from there. Because these two things are perpendicular, that means they form at most 4 right angles, and that's going to be really important. So in this case, in this particular problem, they actually only form 2 because this doesn't extend out. If it did extend out, then yeah, we'd have 1, 2, 3, 4 right angles. Just because it's perpendicular, that's what that means. All right, so I'll go ahead and say that I'll name these angles. Doesn't really matter what it is. Angle HJK and angle HJI are right angles. Now, what is the reason that I'm able to make this statement? Okay, well, that's because, and I'll just say that it's by definition. So, by definition of perpendicular. So this is the reason that I can make this statement right here. So let's look up at the diagram and kind of fill in what I've got going on now. Okay, I've got HJK, and I've just said that this is a right angle. I also have angle HJI, and I've also said that this is a right angle. Why am I able to make that statement? That's because that these segments here and here are perpendicular, and by definition of perpendicular, you have 1, 2, 3, 4 right angles that result. Okay, so now that I have that figured out, I can go ahead and do the next step. So now that I know that these are right angles and they're part of a triangle, I can go ahead and say, well, these triangles, triangle HJK and triangle HJI, are right triangles. Now, how do I know that these two triangles are right triangles? What is the reason that I can make that statement? Well, that's just because, by definition, and you could have worded this a little different if you want, by definition, right triangles have right angles. So that is the reason I was able to make this statement right here, that all of a sudden these triangles are now right triangles. Okay, so now that I have that established, every time I have a right triangle with trying to prove parts of it congruent or whatever the case may be, I'm automatically going to try and use HL congruence. Now, it might not work, but every time I have right triangles, I automatically will think, let me try and use HL congruence. If it doesn't work, fine, whatever, but every time you have these, you should be thinking, hey, maybe I can try this. Okay, so for HL congruence to work, I just need a hypotenuse congruent, which I've got the hypotenuse of this triangle is congruent to the hypotenuse of that one. And I need another leg. Well, I don't have another leg congruent, but I do notice that HJ is a shared side between these two triangles. And anytime you have two triangles sharing an angle or sharing a side, you can make the following statement. So this is the shared side, HJ, right here. So the next part of this proof will say, all right, HJ is now congruent to itself. Why is it that I'm able to make that statement? What's going on with this? And the reason I'm able to make this statement right here is by the reflexive property. By the reflexive property. Okay, so that's really important for you to be able to make that step when you see this diagram that they do share a side. Well, these are now congruent by the reflexive property. So now that I have the hypotenuse and another hypotenuse congruent and a leg of this triangle and a leg of this triangle congruent, I can go ahead and say that they are now, they have the hypotenuse leg satisfied. So I can go ahead and say that triangle HJK is congruent to triangle HJI. And this, what's the reason I can make that statement? By the HL congruence. So that's how I know these two triangles are congruent. We're almost done with this proof. The only thing left for me to do is to actually go ahead and finish off and say, well, how do I know that these two are now the same? So they want me to prove this right here. Why am I able to go ahead and draw the tick marks through here? What is the reason I'm able to do that? And this is where CPCTC comes into play. CPCTC is an acronym in geometry for corresponding parts of congruent triangles are congruent. And the only time you want to use that is after you've already used or shown that the triangles are congruent, whether it's HL, side, 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 angle, side, whatever. Then if there's two other pieces that they want you to prove congruent, like in our case, congruent, KJ is congruent to IJ. If these are the two pieces that we haven't yet been able to get to, but I've just said that every part of the triangle is congruent by HL, then I can go ahead and say that the other two pieces that they wanted me to prove are congruent by CPCTC. So, to wrap this up, kind of summarize everything, the first thing that I did was I restated the givens. And then after that, I just kind of built on those things that were given to me and said, well, what does this mean? What does this imply that I have perpendicular? Well, that I form right angles. And because they're right angles, they're right triangles. And in this case, they were sharing a side, so I could have, used the reflexive property. And then that was enough for me to say, well, by HL congruence, the triangles are congruent. Okay, so then my last step was to say the parts they wanted me to prove are also congruent because the triangles themselves are congruent. That means every angle and every side is congruent. So the corresponding parts of the congruent triangles are congruent. So every part of one triangle congruent to the corresponding part in the other triangle. And that's this proof pretty much wrapped up and done. It's all you have to do to prove this particular one. And these just take a lot of practice. You have to stick with it, really pay attention, and practice these, and you'll get better at them. Thanks for watching, and let me know what you thought. Especially if you need more help, more examples, I'll gladly do them. Thanks, guys.